Okay, so now let's look at our simplified model. As we mentioned, this is not the model proposed in the paper. This is somewhat a simplification of the original model, but we believe this will be the easier way for you to get the idea. Yeah, so we will start with the simplified model. Okay, we're going to discuss the case with a monopoly risk-neutral seller. This seller has the following three options for pricing the data service. She can either price by minutes, or by bandwidth, or by quantity. So that means I'm going to, for example, pricing by minutes means I'm going to offer you some plans. You may pay me some amount to buy a certain amount of minutes for you to get online. Okay, that's the idea. So, or you may need to pay me according to the connection speed you get. Okay, or according to the amount of data you download or upload. Yeah, so that's the idea. We're going to use M, B, and Q to denote minutes, bandwidth, and the quantity. Okay, and here quantity is naturally a product of bandwidth and minutes. You choose your speed, you choose your minutes, and that means you choose your quantity as a product of the speed and the time. So suppose we price according to minutes or according to quantity. Okay, it's possible for us to use a fixed up to plans. That means I may not be able to, let me say that again. If I want to use this fixed up to plan, that means I set a bound, okay, for the usage. For example, if you want to buy minutes from me, you need to buy at least 100 minutes or 2 hours as a lower bound. Okay, that part will be priced at a fixed payment. Okay, at a fixed charge. Okay, you are not allowed to buy any amount that is fewer than what I mean by 2 hours or 100 minutes. Okay, so that's something we call fixed up to plans. Certainly, fixed up to plans may be a consequence of optimization if it is optimal, right? That's possible. And also, if we say there should be fixed up to plans, that means we are putting restrictions on our problems. So we're not going to do that. In our problem, in this paper, we're going to assume that the pricing metrics M or Q are just continuous variables. That means I'm going to design a contract according to a continuous variable M or Q. So given a pricing matrix, the seller is going to design a price schedule. So that means, for example, if I price by minutes, I'm going to design a function called PM of M, and that's going to map a time usage M to a payment PM of M. Okay, so if you buy 1 minute, that's going to be, for example, $10. 2 minutes, that may be $20 or $22, and so on. Yeah, for every possible time usage, I design a payment as the price for that time usage. As we all know, price schedule can be implemented as a menu of contracts. For example, this PM function can be implemented as a two-part tariff. You tell me your type, and then I give you an amount of minutes, a time usage, and a price you need to pay to me. Okay, where theta is the consumer's type. So that means I can implement a price schedule by setting this two-part tariff or menu of contracts. Okay, instead of design one function, I'm going to design two functions, and what the agent or what the consumer should do is to report his type. So that means a price schedule is an indirect mechanism, and a menu is a direct one. Yeah, and we need to do this so that we may apply, for example, revolution principles or all those standard ways for solving continuous type problems. For types, we say that theta is a uniform random variable between 0 and 1 is the consumer's type. With this type, in our simplified model, the type theta consumer's utility is the following. So it's a little bit complicated, but let's see this one by one. Suppose the quantity and the bandwidth are below a certain threshold, then the utility function is increasing and concave in quantity and increasing and concave in bandwidth. Okay, treat Bm as a single variable Q. Then you can see the first part is increasing and concave in Q. The second part is increasing and concave in B. If, for example, quantity is above the threshold, then we're going to assume that it will become constant. And 1/2 times theta squared is exactly what you may get if you plug in Bm equals theta in the first part. Okay, so that means the first part may become constant when Bm is too large. Or if the bandwidth becomes too large, then again we plug in theta into B here in the second part. It will also become 1/2 theta squared. So that means, for example, if we draw something for the second part, then it will look like, okay, this is B, this is the utility function, I mean the second part of the utility function. Then it will be something like this, okay? This is your theta. Below theta is increasing and concave, above theta is constant. So this allows us to monitor, to model the fact that even if you are allowed to get unlimited usage on, for example, quantity, on minutes, or on bandwidth, you are not going to get unlimited utility. Okay, so that's the idea of a constant, eventually a constant result. So as we mentioned, the first parts, okay, this one and this one, they together make U increasing and concave, and I mean non-decreasing, because after the threshold it will become constant. And they also make this function U increasing and concave in M when B is fixed. So if as a consumer I get a fixed bandwidth, then my utility function will be increasing and concave when I consume, when I use more minutes on internet or any kind of data service. Okay, the second part is also increasing and concave, and that makes U increasing and concave in B when Q is fixed. So suppose I have purchased a fixed amount of data plan, the quantity is fixed, then somehow I prefer faster bandwidth, right? I prefer faster connection speed, but after a certain threshold, I don't care about any improvements. So one main character here is that unlimited usage does not give unlimited utility, because as a consumer, even if you can get a very large connection speed or very large minutes, whatever, after a certain threshold, you don't care about anything more. So let's see something more about the functional form, this one. And this is the first possibility of our utility function. This will be the case when Bm and B are both smaller than theta, are both small. So here we are assuming that consumers, if it has stronger preference for Q, here, then he will also have stronger preference for B here. What does that mean? We say consumers are different, are heterogeneous in their preference about quantity and their preference about connection speed. Okay, that's true. But here we reduce the two-dimensional heterogeneity to one-dimensional. we assume that if one guy cares about data, then he also cares about bandwidth. So this is certainly a limitation or a restrictive assumption, because we know in reality this may not be the case. If I prefer high speed, I still if I prefer high speed, it's not always true that I also prefer high quantity, right? Or the reverse thing. So when we make this assumption, when we make this single dimensional heterogeneity assumption, then somehow that's too restrictive. But we do so because multi-dimensional screening is just too hard. Yeah. So it may be a natural and convincing way to extend the model and analysis in this paper. Also, here, let's note one thing. A higher time usage results in a higher utility only if it corresponds to a higher data usage. So let me say that again. Suppose the quantity is fixed. In that case, if you use more minutes, that means the bandwidth must become smaller, or the average connection speed you choose must become smaller, right? So if you cannot consume more data, then consuming more time itself does not make you happier. Okay, that's a characteristic of this utility function, and we believe that's somewhat reasonable, because using more time on internet or whatever simply does not give you higher utility. It depends on how many you can see, right? Also, because there is no cost for offering the service, the socially efficient consumption will maximize each consumer's utility. So that means suppose if we want to find the socially efficient allocation or consumption, that means the seller should set the prices to be free. Okay, all the services are free, and then each consumer will be able to find B and M to maximize the utility function, and that's socially efficient. It's just that the seller does not earn anything. So let's see what's socially efficient. The first order condition with respect to B and M tells us that we have these two equations, and then B will be equal to theta, and M will be equal to 1. Put this in your mind, as they will be the indicator of efficiency, and they will be compared when we solve the seller's revenue maximization problem. We're going to see that when the seller wants to earn some money, will we still have efficiency? Will we see any efficiency loss? That will be our questions. So anyway, this can be done. Okay, so we need to specify the timing. First, the seller determines the pricing metric. Okay, one of the three: minutes, bandwidth, or quantity. And then, given the pricing metric, the seller needs to announce or to design a pricing menu. For example, if she prices by minutes, she needs to design this menu. Yeah, and we're going to see all the three menus later. After the sellers does this, the consumers need to do their things. Consumer will self-select one contract in the menu. So you see there are so many different options for you. Okay, then you can buy a contract by paying that amount and getting that service. For example, you see there are 1 gigabyte per month for $300, and 2 gigabytes for example, $500, and so on and so on. You pick one of them, sign a contract. Each consumer will then adjust that variable that is not specified in the contract. For example, if the seller prices by minutes, okay, then the consumer will sign a contract to get a certain amount of time. Then the consumer is going to choose the connection speed, the average connection speed, by adjusting what's the software or system he wants to use. Okay, if the seller prices by, for example, bandwidth, the consumer get a fixed connection speed, then the consumer will choose how much time he wants to spend on internet or data services. Okay, so that's the timing, pricing matrix, pricing menu, and then select one contract and do the after sales selection. Here we have adverse selection because we have hidden type, and afterwards we have hidden action. Okay, so that's the model. In the next video, we're going to do the analysis. Thank you.